Hello everyone, welcome to Adson Engineering Academy. It is me, your tutor Adson, and today I'm going to introduce to you a new topic, moment distribution method, and we solve a problem. So please follow all the steps and you'll get to understand very well. So this is our first question that we are solving under moment distribution method. I would love that you follow this critically in each and every step, write what is required. So the question is given where we have a fixed end and we have a roller support and a roller support here. The first step on what you need to do is, first of all, give this joint the name. Like, let's number this 1, this joint I will call it 2, then I will call this joint what? 3. Yes. Then the second thing you have to do is get what is called the stiffness. And how do I get a stiffness? Straight away, let me have what I call the member. And where are the members that I have here? I have a member here 1, 2, and then a member 2, 3. So I have a member 1, 2, and then I have another member 2, 3. Then what else do I need to find the stiffness? I have K. Stiffness is given by moment of inertia Li out of the length L. So what is the moment of inertia for a member 1, 2? That is 3I. Divide by what is the length? It is 10. Then what is the moment of inertia for member 2, 3? It is given to be 2I. Then what is the length? It is also 10. 5 plus 5. So you find that a relative stiffness in this case, or the ratio, if I multiply both this by 10 by 10, so you find that the ratio here is coming to 3, this one will come to what? 2. So whatever we have got here is what we call relative what? Stiffness. Okay? So relative stiffness. So since we have found relative stiffness, now what is important is us to get in our next step to get what is called distribution factors. Okay? So we need to get what is called distribution what? Factors. And now distribution factors, I'm using letter DF to represent it. It is given by the formula that a stiffness of a member K out of total what? Total stiffness that we have, summation of the K. So if you add up this relative stiffness, you will come to total what? Stiffness. That is what? Summation of K, which in this case 3 plus 2 is 5. So that means there, if you're getting the what? The distribution factor, you have to get from a joint, because at the end here a distribution factor, of course definitely it will not be there because it is fixed, it is 0. Then when we have a roller support or hinge here, that distribution factor is 1. But in the middle we need to find the distribution factor. So I'll find a distribution factor for a member 2, 1 from here coming this side, because you find at this joint. Okay, so this is going to be summation. What is the stiffness of member? This is same as this and this. Okay, so this is 3 out of 5 and it is equivalent to 0.6. And then what about the distribution factor for the other member? 2, 3, starting from this joint. Okay, 2, 3 is going to be equals to 2 out of 5, and this is equivalent to 0.4. One keynote is that summation of the distribution factors at that joint, at a joint, must be equals to unity, which is 1. Check it. 0.6, 0.4 at a joint, this joint 2, it is giving us 1. Then you are correct. Next step, finding fixed end moment. So you have to follow step by step from stiffness to distribution factors to fixed end moment. Let's move. Yes, so I am going to use FEM to represent fixed end moment. And fixed end moment, it happens on, let's take the first beam. The first beam is like this, is having a UDL. Okay, so if I say fixed end moment, that means both sides is assumed to be fixed. So I need the moment at this point and I need the moment at this point. Okay? The sign convention is that the one which is moving anti-clockwise is taken as negative, and the one which is moving clockwise is taken as positive. Okay? So let us go far and get fixed end moment. Fixed end moment. Allow me change this. Fixed end moment MF 1, 2. I am moving from first joint to the second joint. Okay, that means it's the first one. So this is having the formula minus WL square out of 12. Mark this. I said each step I will give you the formula or what to do. So this is what we take in this case. So we substitute. What is W? W is the value of the UDL there, which in our case is 12. So this is minus 12 times L, which is 10. And this is 10 what? 10 square out of 12. The answer here is coming to minus 100. Take note of that. Now, from that same information, I can get MF, which is 2, 1, because this is 1, 2. 2, 1 will be at this point, okay? So this is clockwise, and it's going to be positive WL square out of 12. Why is it like this? This is the formula for the fixed end moment due to when you have a UDL as a load. So you have to take note of that. So we substitute this. This is 12. This is 10 square out of 12. The answer is positive 100. I guess we have got these two things clearly. Now let us have the second beam. Second beam is having this one point load, which is 48 kilonewton. So if you both side is fixed like this, so what happens is that you need this fixed end moment, right? Yes. So what we do here is, what is the formula? Because here is 5, here is 5. The formula MF due to, let's start with 2, 3 from here to here, and this one 2, 3 is anti-clockwise, so it must be negative. So the formula is minus WL by 8. Okay, in this case W is the load. Okay, same thing. So this value is going to be minus, what is our W? 48. What is L? 10. Okay, I hope you can see that. Then out of, what is out of 8? Well, this value, when you press it carefully, you're going to get minus 60. And this is a kilonewton meter fixed end moment. Okay, then lastly on fixed end moment is MF due to member 3, 2. Okay, from joint 3 going to joint 2. So this is going to be positive WL by 8. So take note of these formulas. Positive, why? It is what? A sign convention is taking it as clockwise. So this is going to be 48 positive times 10 out of positive 8. The answer is positive what? 60 kilonewton meter. We are done with finding fixed end moment. Now I will take you to the most important part of this question, that is balancing it to get what the question wants, which is the moment, okay, in this beam. Well, so you have to make a table like this, where in this table the first thing you could write is joint. We have joint 1, 2, 3 as numbered in the question, the first thing we did. Then the second thing is to write the members. We have member 1, 2. Then at joint 2 we have 2 members. Okay, at joint 2 we have 2 members. You have a member 2, 1, and then a member 2, 3. Okay, so that's what you need to take note of. Then at joint 3 we have 3, 2 only. So if you have made this, whatever we have calculated distribution factor at joint 2, we found 3 by 5, which is 0.6, 2 by 5, which is 0.4. Okay, now here I told you that fixed end, there is no distribution there, so you take distribution factor as 0. and then inch or roller, you take distribution as 1, just the way we have considered. Now the fixed end moment, as we have calculated at this joint, we have minus 100, positive 100, minus 60, and positive 60. Up to this point, I believe we are clear. Now let's move to the next step, what we call balancing. I'm going to use B to represent balancing. Okay, so in this case, if I'm going to use this to represent balancing, and for us to balance this, we balanced after taking the summation of what we have at the joint, this common joint. Okay, so what we do here is, first of all, let's look for what is the summation of this. 100 minus 60, it is 40, right? Okay, so this 40 you have to multiply by the distribution factor. What is the distribution factor here? 3 by 5 times 40. So 3 by 5 times 40, you get what? Remember, it is positive. You get positive 60. Okay, you get positive 24, I mean, okay, positive 24. You get positive 24, and since I have to write here 24, but since the answer I have got is positive, the formula, the distribution says, since the answer I've got is positive, it says you have to record it as negative. That's another keyword you have to take note of. So you have to record it as negative. If you get it as positive, you have to record it as negative. If you get it as negative, you have to record it as positive. And then we come here. This is the same thing. This plus this is positive 40. Positive 40 times 2 by 5. The answer is 16. Positive 16. But you have to record it as negative 16. Okay? We are done with balancing. But where we have the distribution factor as 1, the way to balance it is that you carry, if A is positive, you carry its negative in the balancing part. So we carry negative what? 16 here. Take note of each of these steps. It is very important. Otherwise, you cannot continue what? Doing what you're supposed to do, because you have balanced it, this part now. So whatever we have here will basically take us to the next step, which is called carryover. If you're done with balancing, because here is 0, distribution factor is 0, so we cannot balance anything. So we go to what we call carryover. Carryover in this method means we have to distribute at each joint. Like say at joint 2, it's going to add half of what we have here, half of 2 1. I can show you from here. So half of this 2 1 will be carried over to 1 2. Okay, so half of 2 1 will be carried over, so you can use an arrow. Half of it will be carried over to this point, and half of what I have here should be carried over to this point. Okay, so you realize that half of this is going to be negative 12. Okay, then the same applies here. Half of this is supposed to come here, then half of this is supposed to come here. So this is minus 30, and then this is minus what? 8. So that is how to do carryover. You take half of what you have there at the other joint, then you bring to this part. Now, since this is what we're supposed to do, we have to do it repeatedly until we obtain the final answer. So let's move and repeat again balancing. Let's balance again. Remember, the balancing takes place only at this common joint, this joint here, joint 2. So what do we have? Here is 0, because there is nothing we have carried over. Here is 0. So what is remaining is minus 30. So this minus 30 again, what you do is you have to multiply each by what? The distribution factor. So minus 30, if I multiply by 3 by 5, check from your calculator very well. What will you get? The answer I'm obtaining is 18, and it's negative. Since it's negative 18, you have to record it as positive. Okay, so this is going to be positive what? 18. Take note of that. I'm writing positive because I need you to know. Then what about negative 30 times 2 by 5? This is positive 12 now. You're recording it as positive, but the answer is negative. Okay, that is the method you have to follow correctly. Now, since we are done with the middle part, what about this part? Because the distribution factor is 1, then since it is negative, we have to carry its positive here. Okay? Yeah. But where the distribution factor is 0, there is nothing we can carry except 0 also. Fine. Now, let's move and do again another carryover. You have to do it repeatedly. Okay? So, I'll tell you where to stop. Now, here in my carryover, I will carry again a half of this and bring it here. And you know half of positive 18? Positive 9. Then, the same applies what? Here. You carry this, bring it here. So, this is positive 6. Then, this is positive 4. Okay? Yeah. So, up to that point, I believe it is clear. Now, since we are done with carrying over, we need to again repeat balancing. Okay? So, let's balance again only at this joint. So, what is remaining here is now 0 and what? And 4. So, positive 4. Positive 4 times what? 3 by 5. What do you get? Positive 4 times 3 by 5 is positive 2.4. Okay? So, positive 2.4. If it is positive, you have to write it as negative. 2.4 I mean as negative. Okay? Then, what about 4 times 2 by 5? This is 1.6 positive, but you have to record it as negative. Okay? Yes. Then, I believe up to that point it is clear. Okay? So, if that is the case, remember when we are balancing, if the distribution factor is 1, that point should also be clear. You have to carry the negative of that same value here, the opposite sign of that same value down. Up to this point, we're clear. We move to the next. That is to say, we have to carry over again. So, let's write CO, carry over half of this here. Okay? So, half of minus 2.4 is minus what? 1.2. 1.2. Then, this one here and this one here. So, this one is minus what? 3. Okay? So, minus 3. Then, this one is minus 0.8. Okay? So, you can start balancing even from this one. So, let's balance. If I start from this one this time round, so positive 0.8 carry it down here. Then, let's have this one. So, my 0 and minus 3, minus 3. Minus 3 times 3 by 5. Okay? So, minus 3 times 3 by 5 is going to bring us to the answer of 1.8. And since it is minus 1.8, when you're recording, record it as positive 1.8. Then, what about here? So, minus 3 times 2 by 5. So, this is 1.2. Okay? It's negative, but you record it as positive. So, I believe that line is clear. Now, the next thing again, we have to do carryover. Okay? Carryover. So, carryover half of what? This one here. So, this is 0.9. Then, half of this one here, half of this one here. Okay? So, this is 0.4. And then, this one is 0.6. You can start balancing from where you have 1 also. So, carry negative of this 0.6 down here. Okay? Then, what about at this point? What we have at this joint 2? We have only 0.4. So, what we have at the joint 2 is 0.4. So, multiply with the distribution factor. 0.4 times 3 by 5. What do you get? So, I get positive what? 0.24. Okay? So, since I have got positive, we are balancing. Since I have got positive, I have to record it as negative. Good? Then, 0.4 times 2 by 5. What do you get? 0.16. 0.16. Since it is positive, I have to record it as negative. So, you have to follow all this rule clearly. Then, we again do carryover. Okay? So, if we do the next carryover, what shall we get? Okay? So, I will have here half of negative 0.24 is negative 0.12. Then, what is half of this one will come here, half of this one will come here. So, this is 0. If it's this is 0.3 but negative. Okay, negative. Then this is 0.08. Okay, so you realize that this thing is reducing, going towards 0 now, and I can stop here and find what is called final moment. Final what? Moment. So what will be my final moment? Okay, so the final moment, you have to add from fixed end moment, you add all this until you reach what? Here. Okay? So this final moment is coming to minus 103.24. Okay? 0.24. Then we're having this one is coming to 93.34, and this one is coming to minus 93.34, and this one is coming to 0. Okay, so it's coming to 0. Why? Because if you are to do the next balancing, you find that you have to carry what? Negative 0.08 here. Okay, yeah, so it comes to 0. Now to check your answer if you're right, make sure at this joint the values are the same except different sign. One is positive, one is negative, but a different sign. That means you are fine. To complete your analysis in this question, we are supposed to draw the moment. These values we have got, we have to sketch it. Okay? So, and for you to sketch it, it is not something hard. What you do is draw your line. Okay? This is our center line. Then this is the first point, and at joint, this joint, we found that the value is minus 103.24. Okay, so I will mark it up here. Okay, if this is what I have, just mark that is the moment at that point. Now since I have this point and I have the point here, so this thing is, since it's a UDL, it's going to curve like this and go up again. This is a UDL, so it will come to this point. Okay, it will come to this point, which we are calling it 93. You can write it, this is 93.34, and then it will find, because a load is point load is in the middle here, so this will come down again like this. Then it will now go back to what? 0. So this is how you're supposed to sketch for that moment. You can just indicate it, this is what? 103.24, and this side is negative, down here is positive, here is positive, up here is negative. Okay? Yeah, so basically that is how we're supposed to solve and sketch for it. We're supposed to sketch on the moment diagram. Thanks so much for watching that video till the end. We have come to the end and we have seen how to solve, so please follow the step. I'll be putting the scheme of the moment distribution in the description, so try to follow it each and every step. Please also remind your friends to like this video, share with them, comment, and above all subscribe to this channel so that you don't miss any of my videos.